Welcome you all once again to this Abaqus Python YouTube channel, and this is the Abaqus Python Scripting Learn with the Concept lecture series. In this lecture we will see how we can save the images from the Abaqus, and saving the images with different orientation, highlighting different entities. All these options we will see. So let's go ahead. So first of all we will just go through the basics and how the flow will be, what we have to do, what options we have to make in general in order to save the images from the Abaqus. First of all we will use the Abaqus CAE. We will use the manual options, and once we use the manual option to save the images, Abaqus records all the information in the replay file. So we will go and see the replay file, and from those replay file we can understand the commands, what commands the Abaqus has used, and we will try to understand these commands from the user manual of the Abaqus, and try to get all the sense of options that these commands has used. And once we can understand those options in certain manner, we can use those methods more efficiently, right? So first of all we will discuss some flow. So let's say we are using the ODB actually, so we will capture some contour results. So first of all we have to open the ODB, and then we have to set the ODB to the viewport. So particular viewport we have to show that ODB object, and then we can change some field output, right? And then we might need to adjust some view. We want to see the particular model from particular view, so we will adjust some view, and at the end we will use the save command. So that is nothing but from the file menu we have to select the print option. Okay, so if you choose that option, then one window will pop up to save the images. Okay, so this is how generally we will use actually Abaqus CAE to save the images. Okay, but apart from that we might want to do some other stuff also. For example, highlighting some entities. For example, user may want to highlight some nodes or some elements, or some element set or node set, so that also we can do, right? And also we might want to show particular entity. For example, we might only want to show the particular element set, okay, and might want to take the images, so that also we can do, right? So this is some basic flow, and we will use this flow in the Abaqus CAE. So let's move on to the Abaqus CAE now. So I have opened the Abaqus here. Now let me open the ODB file, and one thing I would like to tell you here is I have set the work directory same as where my ODB file has been saved. Okay, so this is important because while saving the images, the by default path will be the work directory. So my images will be saved in this location only. Okay, my ODB has opened. Let's highlight particular entity. Now let me select some of the elements at here. So let me highlight that. Let me replace that. Okay, and then let's do the replace all. So get back to the original model. So now you can see by default the undeformed shaped is shown here. Okay, and by default the contour that is being shown here in this field output dialog is stress, and from the stress tensor we are going to see here the 1 minus invariant. Okay, so let's go to the deformed shape, and you can see the contours that we are seeing here is the 1 minus stress. Okay, so this is the default contour. So let's change this to this displacement contour. Okay, and now let's rotate the model. Okay, we can use the default views also, for example xy plane view. Okay, and let's go and highlight some nodes. So by default you can see the elements are getting highlighted and nodes also. Okay, so you can see the node is highlighted now, and let's go and save one image. Okay, here we can choose the all viewport and current viewport also. So because we want to save the images from the current viewport, let's change this option to the current viewport. Okay, and in the settings, I think the color is okay, the rendition option, so black and white, grayscale or color. So we want all the colors because we want to see the contours in the colored as a colored image. So in the destination we have to choose this file. Okay, we want to switch to the file, and we just need to specify the file name here. Okay, and here you can see this file select browser, this folder icon. So from this you can choose some particular folder, and there only our image file will be saved. Okay, and then there is this format option. Okay, so these are all the format of images you can save. Okay, so for time being we will just select this PNG option. Okay, and let's hit the apply. So you can see the image has been saved. Okay, so this one is the image actually. So let's see. So you can see the node is getting highlighted, and the view is also whatever we have saved in the viewport. Okay, and another option you can see here is the replay file has been generated. Okay, so we will use this replay file in order to understand all the images, all the commands that is being used in order to create this image. Okay, so now let's use this RPF file that Abaqus has created. Okay, so let me just change language first. Okay, what I'll do is I'll just segregate the commands that are being written in this replay file. That will be easy for us to read these commands and understand these commands, and we will search these commands in the reference guides. Okay, so for that just let me segregate this. So in this file you can see that these commands till this line, all these commands are being created when you are launching any new session in the Abaqus. Okay, so there is nothing you are doing, you are just launching the Abaqus CAE. Okay, so let me just copy all these commands as it is. So in a brief, let me just explain you. So these are the import statements. So it has importing these Abaqus and Abaqus constants. Okay, and then it's importing some more modules. For example, CAE modules, right? So CAE module, what it basically imports is it imports all the modules that are there in the CAE. For example, material module, assembly module, all these commands, all these modules, right? All these it is importing. Okay, so from this line we are actually doing something in the Abaqus. Okay, so first of all, what it has done is it has opened the ODB, and next what it has done is it has displayed that ODB into the viewport. So after that we shown some element sets and stuff like that, right? So those command it has been recorded here. Okay, so what it has done basically is, first of all, it has created some leaf object. Okay, so why these leaf objects are important? Because anything that you are going to show on the viewport, that has to be first of all created using the leaf object, and that leaf object only you can show on the viewport. Okay, for example, we have created one leaf object from the element set, right? So this is the element set we had shown, and this leaf object then it has shown onto the viewport. Okay, so that's why this leaf object are important. Okay, so and next we can show the default models. There is an option where we can show full model also. So that is the one Abaqus constant is there in the Abaqus called as default model. Okay, next what we have done is we had switched on to the deformed contours, right? So by default Abaqus shows the undeformed shape, so then we shifted to the deformed shape in order to see the contours. Okay, so this is what Abaqus has written here, that it has shifted to from undeformed shape to deformed shape. And next what we have done is we have switched on to the different contour, that is the displacement contour. And next what it has written some lot of commands which are related to the views of the model. For example, whenever you are rotating any model, right, all these commands will be stored as a view command. Okay, so that's why these views you are seeing here. Okay, so let me just copy one thing. Okay, and these view commands are one of the most difficult command in order to understand this, because there are a lot of options and there are a lot of basics goes into it, because it comes with the camera setup and camera positioning and all the vectors and all those things. So this is one of the difficult command. Personally, I feel this is a difficult command to understand. And then what, and also some default views we also can show. Okay, and at the end, this is the one, this is the important command that we are looking for, right? Saving the image file. So let me just save this Python file. Now we have this Python file which includes almost all the commands that are required to create an image file from the Abaqus. Okay, so after this we will see one by one all these commands, how they are working and what are the options, and how we can change this option for our requirement. Okay, so now let's go ahead and see what are the methods that this replay file has and what are the options. Let's try to understand those. Okay, so as we have seen earlier, so this is the text that is already been created, or commands already been created when we are opening any Abaqus session. So there is nothing we can do here, but based on the scripts that we want to write below, according to that we can use some of the import statements and we can remove other import statements. Okay, so at this point, so we don't need this actually, this import statement, because we are not using any CAE modules, we are using only the session, right? And apart from that we are not using any other modules, so we don't require the CAE modules. Okay, so for our purpose, the Abaqus and Abaqus constants, these two modules are enough. Okay, then the first command that we are going to see here is the openOdb. So I have opened this scripting reference guide. So basically where it will come is because this is the ODB related command, right? So in the left hand side, in the bookmark side, right, here we can see the ODB commands. In the ODB commands, it should be there somewhere here. So here we can see there are a lot of commands available, and here you can see this openOdb. Okay, so here you can see the two openOdb methods are there, right? So what is the difference between them? So first one we'll go. So what this openOdb method actually does is it open any existing output database that is available in the directory and creates the new object out of it. Okay, so here we are not creating any new ODB, we are opening one already existing ODB file and creating one new ODB object. Okay, so both these commands doing the same thing. Okay, but the difference is here there is some information given, right? So how we can use this particular command method is we have to import the ODB access. Okay, and let's see what other is saying that. So here it's saying that import visualization. Okay, so this is one of the differences we had seen previously, I think in the first lecture or second lecture, where we had said that you can use this ODB access without needing any Abaqus license. Okay, but whenever you are using other than this ODB access, for example visualization, then you need Abaqus license. Okay, so basically what it means is you can use this particular method when you don't want your Abaqus license to be get used. Okay, so this is important when you are running your Python script using that Abaqus Python command in the PowerShell, right? Windows PowerShell or terminal if you are using Linux. Okay, so first of all we have imported import ODB access. Then in this module there is this openOdb method, so that's why they are giving the reference of this ODB access module to use this particular command using the dot notation. Okay, next one is import visualization. Okay, so whenever you are importing in visualization, then the openOdb method is there, which is reference in the session actually. So this is something different from the ODB access method. Okay, so which one of these we have used here? We have used this session, right? Okay, so here in the openOdb using the visualization, the required argument is called as name. It says that you only need to specify the ODB file name. Okay, and in the option arguments you can specify the path. Actually here in the name you can provide the full path, because we have seen right here, we have already given the full path here. Okay, that also is possible. So next what we have done is we have created one ODB object. Okay, while by opening one ODB file. Now we are showing that ODB object into the viewport. Okay, so set value is what this method usually does, is it changes the particular contents of the object. So here object is the viewport. So let's go ahead and see where the viewport objects are. So in the canvas command we will see this. Okay, viewport object. Okay, so if we click on this, so first of all obviously it will be a constructor, how we are creating the viewport, and because we have used the set values here, right, so probably the set value will be somewhere below. So here you can see the set values. Okay, so from these what we have used is this displayed object. Okay, there are a lot of other options we can use in the viewport. Okay, so first of all in the set values we have used these displayed objects. So first of all this is the optional argument. Okay, there are no required arguments for this. Obviously this is the case for every set values method. So first of all we have used the displayed object. So what it's saying is a displayable object. Okay, objects you can show is a part object you can show, assembly object you can show ODB and other things we can show. Okay, and let's see the second option. You may want to use this sometime. So displayed mode. So what it's saying is, it's saying that a symbolic constant specifying the display mode of the viewport. Let's check out the values what we can give. So here there is single and overlay. So single means you want to show only single object. Okay, overlay means you can show multiple objects. So this is you can use when you want to show multiple object into the viewport. Then there is this leaf objects. So first of all, what it's DGO. So there is no reference given above. Okay, this is one of the strange thing I had noticed in the replay file actually. So there is no import statement regarding this DGO. So it's something related to the display ODB toolset. Let's search this method. Okay. So at some point, if you don't know where the particular object is there in this tree, then you can directly search that object. Okay, so it's 16 point something, so it should be here. Yes, so in the display group, so here you can see there are a lot of leaf object methods that are there. So from the various entities you can create a leaf object. That means you can show various entities onto the viewport. For example, let's say, so leaf from node levels. Okay, or leaf from node set. So what we are concerned here is the leaf from element set. Yes, so here you can see this. First of all, you have to import some statements, right? So what it's saying is display group ODB toolset. So this is the statement you have to import here. Okay, which is usually not been imported by default actually. So now your script is completed actually. So these are the some minor changes you have to take care of. Okay, so because it's creating the leaf object, right? So that's why this is a constructor actually. So what it's saying is this method creates a leaf object from a sequence of element sets. Okay, so multiple element set names you can provide here. The only required argument is this element set names. A sequence of string. Okay, a tuple or sequence of string which specifies the name of those element set, or you can specify the single element set also. Okay, so here how we have defined here is we have given the sequence only. We have given this bottom face and element set name in the parenthesis, right? So it's a tuple, but it contains only one value. Okay, then the next thing is we are specifying or we are showing this leaf object onto the display. How it is shown here is in the viewport there is this ODB display. Okay, and in that display we are showing or we are doing some boolean operation in the display group. So what we had done is we had replaced this element set onto the viewport. So that is a some boolean operation we have done. Okay, so in this ODB display object, okay, we are changing the values of this display group. Okay, so first of all we have to see where this display group object has been created. Yes, here it is, right? So in the display group object, all the things you can do, you can remove, you can replace, you can either intersect, all those things you can do. So what we have used here is the replace. So this method replace the contents of the display group with the specified item. So whatever the content there in the viewport, it will replace all those contents using the particular object you have given as a leaf object. Okay, only required argument is a leaf object. Okay, so here the leaf and then the leaf object we have provided here. Okay, at this point you are only seeing this bottom face element set in the viewport. Now we are creating again one leaf object. So in the leaf it's saying that a leaf type, what is the leaf type from which we are creating the leaf object. So there are a lot of symbolic constants are there. So first one is the empty, there is nothing we want to show. Then the default model, all elements, all nodes, all surfaces. We have used this default model. So what it does is it's regains or it shows all the models that is there. Okay, at this point in our viewport the undeformed shape is shown, but we want to show now the deformed shape. So in the ODB display we want to change the display options. So what we are doing, we are not changing any content out of it, we are not changing the entities. The only minor changes we are doing, how the colors or everything is going to change in the viewport. So that's where comes the display options. Okay, so let me just copy this, it will be easy to search. Okay, so display options object. Okay, so how we are going to use this import visualization. Okay, so that means we have to use GUI mode and not using that Abaqus Python commands in the PowerShell or terminal. Then there is this set value method. Okay, and then what we are doing, we are changing the plot state. So there is this undeformed, deform, contour on undeform, contour on deform, all those things are there, right? So either out of this we want to show the contours on the deformed shape. So we want to see the stress results or displacement results on the deformed shape. Okay, so if you don't want to see any contours, then you can use this deform and undeform. In that case there will no contour will be shown, only the shape will be deform or undeform. That is there. And next one is the set primary variable. So in the ODB display object, okay, let me search that ODB display commands. Okay, ODB display object, primary variable, right? So what do you mean by primary variable? So primary variable is nothing but the color contours that you see in the viewport. That is what we call as a primary variable. For example, if you are seeing the results of the displacement, then that displacement is called as primary variable. So apart from that, there is one more variable that we usually need to know is this deform variable. What this deform variable means is, so the deformation that you see, right, in the viewport, so a particular object is bending or having gone to some distortion. So what that distortion is calculated from, so the variable from which it has calculated is called as deform variable. So by default it will be a displacement will be set as a deform variable, but apart from that any vector quantity you can specify as a deform variable. You cannot put a scalar quantity as a deformed variable, you cannot put tensor quantity as a deformed variable. So you can put the force vector, right, as a deformed variable. So that also you can change. Okay, so that's the difference between primary variable and deformed variable. Okay, so what it's saying is this method specifies the field output variable for which to obtain the results. So the required arguments are a variable label and field. Okay, so these are the both exclusive, mutually exclusive. So field is nothing but the field object you can provide, and the other one is the variable label, so a string or something. Okay, and then there is this output position. This is some important thing to note down. This output position is the position at which the calculation results has been calculated. For example, by default any stress results will be calculated at integration point. Okay, and any displacement results are calculated at nodal point, right? So if you are showing the stress result, then you have to specify the integration point. Okay, and if you want to show the displacement result, then you have to use this nodal. Okay, and one more important point here is the refinement. Okay, so first of all the variable, then the where this results are shown, and then there is this refinement. So refinement is applicable only for the contours which has components and the invariants. For example, displacement has three components, u1, u2, u3, and also from these three components we can calculate the magnitude, right? So that's why this refinement you can use. But for example, pressure, so pressure is a scalar quantity, so there is no components and there is no invariants, right? So in that time you don't have to use this refinement. Okay, in the argument here you have to specify first, is it a invariant or the component. So this is the symbolic constant you have to specify, then comma, then the name of that invariant or the component. The next one is the view command. So let's see where that view command is. Yes, view object. So what we are using here is this set values. So there are a lot of options will be there in this, and it will be very difficult, and in detail we have to study in order to understand these options. Still, if you want me to cover this, how these options are created and how we can manipulate and change these options, so I can create one lectures going forward. Just let me know in the comment section. Okay, so in brief I just want to show where these options you can read about it. So in the Abaqus user guide, go to the part 1, interaction with Abaqus CAE, right? Then you can go to the manipulation, the views and controlling perspective. Okay, then there are this lot of options you will see, understanding camera modes. Okay, all these definitions and all these concept that you are seeing here, right? All this you will see while reading this different arguments. You can then change this option, give different value to this option and get the results what you want. Okay, and also you can also set any particular view into the viewport. For example, what I have done is I have set the front view in the viewport, so that also you can do. And the last one is this print to file. Okay, so this will be there in this session. Okay, in the session there is this print to file. This method prints canvas object. Okay, canvas object can be created from different objects actually. So it can be created using viewport, using some drawing area or something. Okay, so this method prints the canvas object to a file using the attributes stored in the print option. So the first one is the require argument. The require argument is the file name. So this file name you can provide with or without extension. Then the format, these 5 format you can give. Okay, the default one is the PS. Okay, then the canvas object. So canvas object, what we had given here is the a sequence. It has to be a sequence of canvas object. Okay, so canvas, as I said, canvas can be created from viewport, text string and the arrows. Okay, so now we have seen all these commands. Let's try to run this script. So the view will be set as the front view. Okay, so let's run this script. Just running the script. Okay, so it is run. This is the image created when we have used the manual options, and this is the image it is created right now. So this is the previous image. Obviously the views are different, okay, but one thing I'd like to discuss here is here you can see when we had done the manual options and created the image, you can see the node is highlighted here, right? But in this case there is no node highlighted. Okay, so why this happen? Because the same options has been captured in the RPA file, but when I run the script, the node is not highlighted. So till now you have seen all these commands, right? But no command has been written here which is highlighting that node. Okay, because there is no specific command written here, that's why we are not seeing any highlighted nodes. Okay, so specifically we have to use some command in order to highlight the node or element. So this is one difference actually where the will not be captured. Okay, so here it is there, right? Highlight command in the canvas command. So it says that highlights command are used to highlight the objects in the current viewport and remove the highlighting. Okay, so there are two commands, one is for highlighting and the other one is for unhighlight. Okay, so first one, it says that this method highlights an object into the current viewport. So the path is the highlight, so there is no model required in order to use this. Okay, and what is the required argument is the object. So what is the values we have to give for this option? What things we can highlight in the MDB model database? All these things we can highlight. Okay, but for the ODB we can highlight only node, element and display group. Display group is something which is related to the entity, for example node set, element set. So in order to highlight this node, we have to we can give the node option here. But what specifically we have to give? An object. Actually we have to give an object. So let's see, I'll just try to highlight this one, this node. So this is the 10 node label. Okay, but I cannot just simply put the node label. Okay, so I have to create one object out of it. So there is one command in order to create that object from the node label. So this is the command we have to use, get node from the label. Okay, but simply we cannot write this name, this method, right? We have to give some reference in this tree. Here you can see in the ODB access. Okay, so what I'll do here, session is I don't require it. So what I'll do is I'll ODB, then going to this root assembly, then instances, then what is the name of the instance. So now we have to check the instance name. So how do I check that? So first of all you can go to the group, display group, and in the part instances you can see this stand 1. Okay, and in other words you can also see o1.processAssembly, then instances. Okay, so there is only one instance, right? So I can directly copy this, then I can use this command now, get node from the label. Okay, then what is the required argument is label. So the option for this one is the and int specifying the node label. Okay, and I'll just assign this one to the some variable node, let's say, and now I can use the highlight command. Okay, okay, now let me change the name of the image. Let me run it again. Okay, here you can see the node has been highlighted. So this is the original, this is the current image. Okay, so yeah, so yes, I think that's it for this lecture. Okay, so let me, if you have any further question and you want me to create any new content as per your requirement, I'll be happy to do that. Please let us know in the comments. So stay safe, be hungry to learn. See you, bye and tata.